So yeah, without further ado, I'll turn it over to Peter.
Okay, hello everyone. Hope you're all doing well. I'm Peter James. I'm a data and evaluation consultant focusing on legal aid, legal services, and I formerly worked at the East Bay Community Law Centre as their data and evaluation manager. So probably a role somewhat similar to what many of you here have on the call. Um, yeah, so that's my background. Today's session is going to focus on a, analyzing census data in relation to case data in Power BI. And, talking to Mary about the types of things that people are interested in, I think we came to the view that census data was a perennial topic of interest. And also there's lots of interest in Power BI. So the idea was to try and put those two together in a kind of talk that would hopefully offer something to everyone. And so just to sort of set the context a little bit, I think many organizations often are operating in a context where you are serving a a, a geographic area that has different uh, geographic units in it. So it might be that you are serving multiple counties or you're serving multiple cities, and so on. And I think that one of the questions that we often have is, well, how effectively are our services reaching the communities in across our service area? And I think that this often comes up in different contexts. So it might come up in strategic planning when organizations are thinking about, what their big picture plans are for the next 5 years or so on. It might come up in decisions about office locations, what to do with helplines. I've seen it come up in planning for outreach. So if we're going to do some community presentations or we're going to put some extra resources into forming connections with local organizations, like where should we be putting um, our resources so that we can try and um, sort of achieve equal access across our service area. And so, um, the what I'm going to try and talk through today is an example of how we can put together census data with the data that we have on the services we're providing from our case management system to arrive at an accurate assessment of where we stand in terms of outreach in terms of our coverage of different parts of the service area. So I will just start sharing my screen to begin with. Uh, as we get going. Okay. So can you see that we've got I'm highlighting the analyzing access rates example? Okay,
Yes.
right. Thank you. Okay, so yes, if you want to go and download any of this afterwards, I think Mary or Shelley will be able to share the link, so you'll be able to do that as well. I just wanted to note that. Um, So just before we get into Power BI, I just wanted to quickly preview what this might look like in Excel or in a spreadsheet uh, program, just because I think that's more familiar and it will give us a sense of what the process looks like in general and then how it differs when you do it in Power BI, because it is a little it's a little bit of a different sequence, and so I think thought that might be helpful as a starting point. So can you see my Google Sheets open here?
Yes, we can.
Okay, great. Um, okay, so to begin with, I think the first step is obviously pulling out the census data that you need for your service area. The example that I'm going to talk through today is imagine that you have a helpline that is covering the whole of California, so the whole of one state. And in California, we have 58 different counties. So let's say we wanted to do the analysis at the county level. Um, the the first step would be sort of sourcing the data on the relevant population that we're seeking to serve. So um, I'm not going to go into sort of details of getting data from the census website today, but I think the first step for typically in this analysis would be going to the census website and then downloading the data for the geographic area that you're interested in. The data that we've got today is table S1701, and that has data on the population that is at 200, below 200% of the federal poverty level, so a sort of general low-income population. One little note about using census data is that it often comes with a geographic identifier code, sometimes called a FIPS code. And it can be really helpful to include that. If you have that in your download from the census, which you always will, it's always helpful to include that in your data files as you're working because I've found situations where, for example, you have counties or particularly cities that have the same name, and that can cause quite a lot of confusion. And so the FIPS code is always unique, and so that will prevent you from running into difficulties of places with the same name. But this is just a simple table of the data for California. And then here's our case data. So this is an example of just some there's not a lot of info here. It's just simply tons of different cases in different counties in California. And again, you'll see there's the FIPS code there. If any of you are legal server users, then you can actually add the FIPS code into your reports if you have from the county of residence table. So then the next step is sort of actually seeing, well, what's the breakdown of our services by these different counties. And I've summarized this by FIPS code here with a pivot table. And so you can start your analysis with that breakdown by county. So 6001 is the first county in California, and that's showing 333 cases, 2.2% of the total. So then the kind of question is, and the focus of what I'd like to talk about today is, well, how do we then, we know where our cases are, but then how do we relate that to the population that we're seeking to serve? So on this tab here, I've shown how we can kind of join that together and calculate some useful rate information that will help us make sense of this. So to walk through one example, so Alameda County, where Oakland and Berkeley are in California, we have our population there from the census, and then we are using a lookup formula just to pull in the case data, so the number of cases that we have in Alameda. And then there's a formula here to divide the number of cases by the population, but see the population in terms of thousands, so it's a bit easier to deal with, to create a rate. So basically what we're saying is we're handling just over one case per thousand low-income people in Alameda County. So what this does is it helps us to get a kind of uniform measure of the rate at which people are accessing the service across different counties, which may otherwise have very different populations. So, for example, Alpine, the smallest county in California, has just 355 people in this subpopulation, and so on and so forth. And whereas LA is reaching up to 3 million. So what sort of is helpful about these rates is that it enables you to directly compare different counties or geographic areas which have very different populations. So, for example, we've got a higher rate, as you can see here in Butte, even though we had 333 cases in Alameda and 91 in Butte county. Actually, the actual rate of access in Alameda is in fact a bit lower than in Butte because it has a larger population that we're seeking to serve. So that's the general idea, is that we're trying to create this kind of some standard way of comparing access across the counties. And I'll just show a couple of other little aspects to this before moving on to um, Power BI. Um, Sometimes these rate calculations can be a little bit, it can feel a little bit abstract, right? 1.0 compared to 1.35. It's not very kind of uh, maybe easy to digest. So another mechanism that I've used in the past, and I've seen others use, is to use the census data to try to develop an estimate of how many cases you would expect to handle based on the size of the population in each county. So the way that you could do that is in this column here, column H, there's a formula that calculates basically the the fraction of the total population that Alameda County, this first county here, um, like the how much that county contributes to the state overall. So Alameda County contributes to 3.1% of the overall low income population in California. It then uses that in a formula here to say, well, if it has 3.1% of the total population, then it should also have 3.1% of the cases if it was all even. So you can use that calculation to say, well, we would expect all things being equal to have handled 453 cases in California, in Alameda County. So then you can use that, you can compare that to the actual number that you have handled in practice, right? So you can say, well, if we were serving each county equally, then we would expect to have handled 453 cases. In fact, we handled 333. And so we've got a kind of hypothetical shortfall, as it were, there than compared to what we would expect. And similarly, if we drop down to Los Angeles here, um, we that's an example of in this hypothetical example, it's showing that there's more cases handled than you would expect. So that can be, I don't know, to me that feels like sometimes a bit more of uh, a kind of tangible way of thinking about this issue of shortfalls and and so on. So I'll just pause there before moving on to Power BI and see if anyone's got any questions. Nope. All right. I will hop over into um
Peter, it looks like we have a hand up from Zoe.
yeah, hi Zoe.
Hi. I do have a quick question. I know that in California the county is important, but we're in Massachusetts where the county is not important.
Yeah.
Is there something that's like the FIPC code but for a city?
Yes. So
Okay.
whenever you go onto I actually have it here.
Okay.
I mean not for Massachusetts, but I'll show you this. Um, Whenever you go onto the census website, and you download some data, there will be, can you see this column here? Uh, Geography. I'll
I can.
highlight it.
Yeah, I can see.
Can you see that?
I can.
So you will always have a column, whether it's zip code, town, um, um, census tract, whatever geographic level you're dealing with, there
Uh-huh.
will always be something that is like this.
Oh, okay.
And you can read online about kind of the details of this, but basically, can you see that in this column, it has '06 is at the front of everything?
I can.
Is
Yeah.
here. So that's saying that it's in California. So
Ah, okay.
I don't know what the code is for Massachusetts, but
Yeah,
when you download the data for Massachusetts, you'll see that there'll be a recurring number there which
I
represents your
see.
state.
Okay.
Does
Okay,
that
thank you.
help?
Yes, it does. Thanks.
Okay. All right. Any other questions? All right. Um, right, I will pop over into Power BI now. Um, and so just to I'll just hop out of here. Um, I'll just show you to begin with what we're kind of aiming for in terms of an end result in Power BI and how we can, and then the steps that it would take to get there. This is Power BI desktop, and maybe at the end I'll just do a little I'll refer to Power BI service, but this is where if you were building an analysis, this is the program that you'd be working in. So I think that in many cases, um, you know, if you can do the analysis in Excel and get the answers that you want, and it takes you a reasonable amount of time, then that's great. I think that the where Power BI really comes into its own is that for this particular task is that it provides you with access to sort of relatively easy to use mapping software, depending on the type of mapping you want to do. But for this example, it's definitely sufficient. And also it enables you to sort of interact with the data in a more dynamic way than you can with Excel. But so that's sort of to my mind the big benefits of using Power BI in this context. So for example, one of the things that is quite easy to see in the map here, can you all see this clearly? Let me know if you can't. Um, is that you can sort of see geographic clusters that wouldn't be evident from just looking at a table of data. So what you can see here is that you've got darker shaded counties here in Southern California, which represents LA, sorry, orange, and LA, um, and San Bernardino. And so you can see that there's a sort of a cluster of high access rates in that SoCal region there, which you will also be able to see when you sort the data table. So um, Alpine's a very small county, so it's a kind of outlier at the top there. But you can see when you sort the table by access rate, you can see that these three counties here in Southern California, LA, Orange, and San Bernardino, all have high access rates. Um, so yeah, that's just to say that because geographic data is, it is geographic, being able to use a map is really helpful. So I'm going to now just pop into a new Power BI file and sort of walk through what the steps might be to arrive at that end result. I'm not going to do all of it obviously today, but just want to talk through the workflow because I think it's quite different from Excel and can be pretty confusing to begin with. So I just wanted to step through it. Um, so what you would do to begin with is go to get data. So most Power BI workflows would begin with pulling in the data that you are going to be working with. So I will just I will just sort of show what that would look like here. So there are various different ways to connect to data in Power BI. This is an example of the web connector. And in this example, we can just put in the link to the data source. And what you get is a kind of preview. So you always want to, check that this looks broadly right. You can just go straight to load, but it's quite common to use this option here, transform data. And what you'll see when you do that is it opens up this window here that gives you a kind of preview of what the data you're importing looks like. Now, and in our example here, we aren't really going to do anything more with it. It's just going to be as it arrives. But one of the good things about Power BI is that you can sort of build in quite a few data transformation steps that help you with your analysis. So let's say, just as a very simple example, you wanted to change the name of the county into all upper cases, or you wanted to add a categorization or something like that. If you wanted to do any kind of data manipulation, you could do it in this step. But in this instance, we're just going to leave it as it is because it's looking very much like the data that we will need to be working with. And I'll just get the link to the case data here. One thing I will say is in this example, we are using just a kind of a test data set. But if you have legal server or another case management system that can directly connect to Power BI, then that can be another great sort of time saver in terms of having a direct stream of data there. Just going to get Power BI open. So if you want to add this extra data source here, so we're going to add the case data. Oh, sorry. I just need to do the correct one. Okay, so here you go. Okay, and this all looks good. So we now have our two sets of data. So these correspond, if you can recall from the spreadsheet, we had the census data and the case data on two different tabs. So what we'll do now is we've pulled in our data, so we'll just close and apply. And then you often get asked to apply changes. And what that does in Power BI is it basically completes any data preparation steps that you've set up and loads the data to work with. Once you've done that, you can then, Power BI has these different views. You can switch into what's called a table view, and then that gives you this view which looks very much like a spreadsheet and can be pretty helpful for checking that the data looks like what you're expecting, and you can also check that it's got the right number of rows. So that's the table view. I just wanted to show something called the model view, which is something that is quite unique to Power BI, I would say, and quite different from Excel. And so it's something that is worth kind of trying to get to grips with if you are going to be trying to use this program, because a lot of the functionality kind of tends to hinge on this. So basically what this lets you do is it lets you kind of specify relationships between different data tables. So if you remember, we've got the census data and we've got the case data. What you can do in this view here is set the relationship between these two. So one of the things you can do is if you go to manage relationships, I'm going to just ignore the FIPS codes for now. But you can establish a relationship between the county in the census data and the county in your case data. And what this essentially does is it says it's you saying to Power BI that these two are equivalent. So the county in the census data is the same thing as the county in the case data. And that then really helps for when you're doing mapping and creating tables because it understands the relationship. So it says if I see out the word Alameda in the census and I see it in the case data, I actually know that these two are the same thing and should be treated together. Another little tip for working with uh, um, data, if you're doing geographic analysis in Power BI, is to always set the data type or the data category, sorry. So if you highlight a field here like state, and you would want to then go and tell Power BI, treat this as a state or province, and then you'll see that you get this like globe next to it. The same for county. Um, call that county. You want to do the same for all of your data sets. And I'll do the same for county. So that then, when you come to using the map visualizations, that means that Power BI will know what to do with it. One final step in this screen is to a sort of related to mapping is that Power BI needs to understand whether any geographic units, such as counties, are in any kind of hierarchical relationship with each other. So in this case, counties are all contained within a state. So what we'll do here, if you can see here, we're going to, on the census data, we're going to select create hierarchy, and that's creating a hierarchy for the state. Then we're going to click on the county field and add it to the state hierarchy. So what you can see here, hopefully it's a bit small, is that basically the state hierarchy field tells Power BI that all of these counties are in the same state, right? So treat them together. So there's a little bit of prep work that's kind of required to get stuff ready. But once you've done that, it can then be pretty, it then helps you move fairly quickly towards some of the mapping tools. So I'll just move to that now. So this is what's called the report view. It's accessed here, and this is where you really build the end product that you want. So in this case, I'm going to flip us over to the Azure Maps visual, and that will place that on our pane And so we'll now be able to start adding our data to that visual. I'll make it a bit bigger. So under location, we can put in the state hierarchy that we've already started working with. You can see that can you see this here that it's showing California?
Yes, we can.
Okay. And then you need to let's just sort of uh, add, you need to typically adjust the map to make it the type that you want. So I think it was we've got counties here. Show these full map player. Yes. So as you'll see here, because we've sort of identified the different geographic units, Power BI is able to sort of directly understand where to put this data on a map. You then need to typically for any visual, once you've defined that kind of the geographic parameters, you then have to tell it which data you want to start displaying on the map. So in Power BI, you usually display data that you want people to interact with through a measure. So we could have as here our sort of let's say our total population. You then select your data. Then you have what's called a measure, which you can then add into your map where you want. I'm going to switch over now to the finished product because it does take a little bit of configuration to get this exactly how you want. So when you're trying to look at the kind of intent, the compare differences across counties, you often want to show the county boundaries and then have a kind of color gradient so that larger values are darker. So on Azure Maps, you would go into the visuals configuration here. And if you go under filled map layer, if you go into there's a sort of, it says FX there for function. If you go into the function part, you can set a color gradient that is based on any measure that you've created. So the access rate measure that we saw in Excel, I have added that here into Power BI, and so that is displayed on the map there. So you're able then to sort of see all of this data on the map field like that. So just as a final step, just as a final kind of, I guess, plug for why you might use Power BI for this kind of task. Once you've built this map and data tables in Power BI, you could then go to the publish button here and you can publish it to Power BI service, which is basically a kind of online portal that your different team members in your organization could interact with. So if you wanted to have a setup where your team members, let's say people who are managing the helpline or needing to look at this data really regularly, they could just have a link that they could go to, and then they could easily interact with this kind of data in a fairly straightforward way, just almost as though it was like a website. And I think that that makes it pretty easy to consume, and then people can kind of focus on looking at the differences and analyzing what it's telling them. So that's all I wanted to cover today. I'll just uh, see if we have any questions. I'm seeing something in the chat. Ashley, does Power BI allow you to set up a lookup table? For example, if you had a separate table with county and FIPS table, but your case data only had county and the census data only had FIPS, like, can you create a lookup table that matches them? Yes. I'm just thinking about the specifics of this. A separate table. Yes, so there are I can't really sort of go into all the ins and outs of this today, and happy to I'll put my email in the at the end, Ashley. But basically in short, there is a function in Power BI called related tables that basically or related table which lets you do some of the same things that you would often be doing with lookups in a spreadsheet software. So that can help you deal with some of these issues. Um, I would typically say, or at least what I do anyway, is if there are going to be issues such as this, I always try and make sure that the data I'm pulling in has as much of the all of the columns that I'll need at that point, so that the if that's possible, so that the amount of kind of adding and making lookups in Power BI itself is limited. But yeah, happy to follow up about details if needed. Um, any other questions?
Oh, I have a
Yeah.
question.
Yeah, sure.
Sorry, but I didn't raise my hand. I'm trying to visualize the two different locations at the same time. Like for example, um, client's location, and at the same time, my economical description by census tract. So two different kinds of data, but are limited by the location.
Got it. Yeah. So there are, I'm not, yeah, it kind of depends what you're trying to achieve as the end result, but I have seen a couple of different approaches to doing this.
Hmm.
Um, one is to put maps side by side, so or tables side by side. So let's say you wanted to, yeah, look at some economic characteristic of a county or a city's, and then the number of clients you were serving. I've seen, quite common approaches for people to just put the two maps side by side so you can visually see the correlations. Another approach is to use tooltips. So that is where you can kind of have data that pulls up when you hover. Um, just trying to see. Can you see this Power BI again?
Yeah.
So I'll just show you an example of the tooltips. So yeah, you can configure the visual so that you see how it's showing low income population, cases closed, access rate. You
That's
can kind
correct.
of add any number of things that you want there to help people see those things side by side. But does that answer your question? I'm not sure whether it does.
Yes, it does. It does. It's just like right now, it is pretty similar to what the previous question it was related. One data set is by zip code and the other data set is by census tract. So because those two doesn't
Oh,
match exactly, this is why like there are like certain information that might be missing in one another.
oh, got it. Right. So that's, yeah, okay. So for that question, that's quite complicated, but I
Yeah,
will, I'll pull out, I'll just, actually, since we're on a screen, I'll just show um, a really useful tool for this is, it's called GeoCore. Can everyone see this? I pulled it up.
yeah.
It looks kind of old school, but it's really useful. This is something created by the Missouri Census Data Center, and that enables you to use it's called here, so the latest version is GeoCore 2022. I won't go into the details right now, but basically this helps you to do cross-reference between different geographic levels. So, for example, if you wanted to say to have a spreadsheet which told you which zip codes are in which county, then this tool would help you do that. So that it, I think it's quite difficult to kind of deal with this question
Yeah,
like
but
within a mapping tool itself. But if you
yeah.
use a tool like this, you can at least make your input data all at the same geographic level, and then that makes it easier to work with.
So from this tool, I'll be able to get a column that will give me the correlation from the column or like the data that I already have. Like for example, in this case, could be from census tract to zip code or from zip code to census tract.
Yes, precisely.
Great. Thank you so much. This was really helpful. I didn't know about this.
Yeah, fair warning, you may end up down many rabbit holes once you start doing this, but it is useful because it also tells you what percentage of any like you often get zip codes or like you get situations where you might have a zip code that falls across two different cities, for example. This tool will tell you based on census data what how that's split. So that can help you kind of allocate the zip code to the major city, for example, if you wanted to do it like that. So it is really useful. Yeah.
Thank you so much.
Okay. Um,
Peter, would this be a good time also to talk a little bit about geocoding, like how people would get I know in some case management systems, like in legal server, there are certain blocks you can get where it will kind of geocode the address already. And that would mean if you had like a client address, it may tell you things like the census tract or the zip code, but there's other options. But I think you have to be pretty mindful and careful again, because it's client data and client addresses of kind of where you're going to get those boundaries. But depending on the case management system you have, you might be able to get your data by some of these different geographic boundaries based on what's already.
yeah, and actually, I mean, to some extent, that's probably the most important point is that when you start doing any geographic analysis or mapping with poor quality geographic data, you quickly run into problems. So, for example, you may have some records where the client's zip code and their county are actually sort of they're not compatible. So like it actually the data that you have doesn't accurately correspond to the kind of the kind of geographic data that mapping programs will be using. So, for example, someone might think that their zip code is in a certain county, but it's actually in another, or there was a data entry error at intake. All kinds of things like that happen. So, when you have the option to geocode to sort of validate addresses and make sure that the address is fully correct, and then build on that to make sure that the correct address is then pulling in the geographic codes, then you avoid a lot of those issues. So what Mary's referring to is that it's a lot easier if you can just pull out your case data and you have very accurate designations of zip code or city or county, that you don't need to go away and manually source for yourself, because that can be extremely time consuming. And so yeah, you've got options for doing that in legal server, and I think that really is a very solid investment if you're going to be doing any of this work on an ongoing basis. Is there anything else you'd add, Mary, or anyone else about that?
Yeah, I definitely don't want to hog the mic. I just want to say thank you, Peter, for this really incredible presentation. It was such an awesome, clear walkthrough of this process, making me get excited to get back into Power BI and look at this. But yeah, just another note on the geocoding. I think especially it's great if you are taking data out of legal server, if it's already, or whatever your case management system may be, to have it kind of already aggregated in these boundaries is always a great way to kind of protect privacy. Um, so I think, yeah, as Peter was saying, and also, be sure to do your own research as you're looking into tools like Azure Maps. Like sometimes Microsoft is sending the data to a server to kind of like work on creating that map there. So just kind of be mindful if the data is already aggregated by something like a zip code or a county, you're not going to risk kind of putting someone's individual address, that's a client's address, kind of out there, out of your secure systems unnecessarily. So always a good one to keep in mind when looking at geographic data. But yeah, does anybody else have any other questions for Peter?
Well, yes, thank you, and thank you for bearing with my tech issues as I got set up today. I'll put my email in the chat, so if anyone does have any follow-up questions, then please get in touch. Happy to chat. And yes, hopefully either Mary or Shelley can post that link to the files. So if you want to take a look, you're more than welcome to.
Awesome. We'll definitely get that out. And I think we'll also be posting this recording on YouTube for those who weren't able to join us today. Thank you so much, Peter. This was awesome.
All right, take care.
Thanks, Peter. This is great.